everyone, my name is Moyo and I am a software engineer on the C++ cross-platform team. Today, I'm going to walk you through how you can use Build Insights to debug build performance problems in your C++ projects, especially with the new features we've added in the last year. So let's start with what Build Insights actually is. Build Insights is a powerful profiling tool that gives you deep visibility into your C++ builds. It tracks detailed data like function level build costs, header includes, template instantiations, link times, and much more. It's designed to help you optimize workflows, reduce build times, and ship faster. One of our standout success stories comes from our collaboration with Activision. They partnered with us to use Build Insights to take on some of their most complex build performance challenges, and the results were incredible. With Build Insights, they were able to cut build times by 50%. If you're curious about the technical details, there's a full deep dive available on the Microsoft Game Dev blog. That success was one of the many that inspired us to integrate Build Insights into Visual Studio, making powerful build profiling tools more accessible than ever. Now, to show you how Build Insights is in action, I'll walk through a realistic scenario that mirrors something many of you might run into. Let's get started by making sure you have Build Insights installed. To do that, first open the Visual Studio installer, hit Modify on your installation, and under the Desktop Development with C++ workload, scroll down to the Build Insights component, check the box, Install, and you're good to go. Now that we know we've got Build Insights set up, let's jump in. I cloned the Supertox Cart repo to start working on some changes. If you're not familiar, Supertox Cart is a free and open source 3D arcade style kart racing game that is fairly large and complex with hundreds of thousands of lines of C++ code. I made a change mimicking add-in functionality to Supertox Cart's asset pipeline, add-in steps like analyze, purge, and emotion, and I wanted them to be fast and flexible. But at the same time, I wanted to utilize a vehicle compatibility system to validate part combos at compile time. While this was all super efficient in runtime, I noticed the build time shot up. So now the question is, what happened and how do I find out? Let's use Build Insights to investigate. To run Build Insights and my whole entire solution, I'm going to go to Build option and click Run Build Insights and Solution, and then I'm going to click Build. To save us some time, I'm going to cut the build right here and jump ahead to when it's finished. I'll do this a couple more times throughout the video so we can focus on what matters. As you can see, the project is done building and the ETL has now popped up in Visual Studio. Now, let's look at the Include Files view. This view shows which headers are included, how often, and from where, helping you spot redundant includes and optimize compile times. If you want to learn more, you can now click the question mark icon to access helpful documentation and dive deeper into the details. Also, with the new enhancements we've made to this view, it now shows a hierarchy. Parent nodes are the included files, and child nodes are the files that include them. You can now see aggregated time per header across translation units, so it's much easier to see what's hurting you the most. Next up, a small but hugely helpful feature, the new file name column. This came directly from user feedback. Before, we only had full file paths, which made scanning through results really difficult. Now, you get just the file name at a glance, and you can still hover to see the full path. Another helpful feature to use is the new project filter and file path filter features. These work seamlessly together. I am able to specify specific files I care about using the include filter, or ignore files I don't care about using the exclude filter. For example, let's say I want to ignore all files from my Visual Studio installation because I only care about the headers from my project. I simply type the path and then hit apply. And now I know the project I just touched is the Supertox Cart project itself. So I can use the project filter to only focus on that project, since I know that must be what increased the build time. This is especially helpful in a big code base like Supertox Cart. Suddenly, I'm not staring at thousands of unrelated entries. I'm focused exactly where I need to be. Now let's take a look into the functions view, which shows the top contributors to compile time at the function level and turned out to be the key in diagnosing this problem. You notice at the top that there is a caution sign on this execute file operation function, and that there are more than 100,000 force inline calls. Probably not good, right? Now let's see what's happening in this file. You can just double click on the file name right from the results and it will open directly in the Visual Studio Editor. No need to leave the environment or search for the file manually. This is a real game changer for keeping your development flow uninterrupted, letting you quickly analyze, edit, and iterate without breaking your focus. The code I added simulates a deep asset processing pipeline. It's structured to mimic real-world workloads, using force inline across multiple levels of functions with the intent to save the overhead of a function call in performance hotspots. In this case, compile time overhead from force inline was severely amplified by switch-style branching. The same inline function got duplicated for each case. The inline function, perform file operation, is called multiple times inside a switch statement, and that function itself calls another force inline function, process pipeline stage, inside multiple if-else branches. Now, process pipeline stage in return calls two large force inline functions, load track model and convert track to bullet. Since the compiler expands each call separately, this causes an explosion in code size, with inline copies multiplying across every switch case and nested branch. The intent was to optimize runtime, but we're paying for it at build time. So instead of removing force inline, I just changed how the force inline functions were being called. In places where they were called multiple times inside a switch or if-else block, I hoisted them out, so they're only called once. This way, we retain the runtime benefits of inlining, but avoid blowing up the compile time by duplicating work needlessly. Now, another time saver with Build Insights is the ability to right-click on a specific file within Solution Explorer and run Build Insights directly on it. This is super useful when you're zeroing in on a particular issue, like I am right now. Rather than waiting for the entire build to finish, you can focus on just that single file, analyze the impact, and instantly see how changes like reducing inlining affect build times. You can also select multiple files and do this as well. And yep, as suspected, much fewer inline call sites, and the function compiles significantly faster now. So after validating this on a single file, I've run Build Insights on the full build again. So this wasn't just theoretical. The fix held up across the whole build, and build time is down to about 3.5 minutes, which means we saved 1 minute already. Finally, let me show you one more culprit that is less obvious: templates. Here, you can see hundreds and even thousands of template instantiations for compatibility matrix, count wheel, and count body. A combined 10% of the build time is spent instantiating these templates. The templates view helps you see exactly which templates were being instantiated, how often, and where. Without it, this kind of issue is almost invisible. By spotting these patterns early, we can identify unnecessarily deep template recursion, replace with runtime or pre-computed alternatives when feasible, and prevent further misuse of templates in similar patterns. Now let's see what's actually happening in this file. In this file, we're indeed using template recursion calculations to determine the number of valid configurations for different vehicle parts at compile time. This approach ensures that there are no runtime calculations for part compatibility. Instead, everything is calculated during the compilation phase, optimizing the performance of the game and making the system highly efficient. But in this case, however, I could simplify the implementation by introducing a constant expression flag to control the logic, so I could still perform compile time calculations without the complexity of deep template instantiation. Using constant expression here makes the code way easier to read and way easier to debug when things go wrong. And the best part is it also cuts down build times a ton, so it's just better all around. Let me rerun Build Insights and see what happens. As you can see, the build time has reduced by another 17 seconds. And no major templates are being instantiated and taking up significant time anymore. So using Build Insights, I caught two common but subtle build issues: inline functions misused in conditional logic, unnecessarily template instantiations that could be refactored with const expression, and reduce the overall build time by 30% from almost 4.5 minutes to about 3 minutes. Build Insights gives you clarity, precision, and the ability to act quickly when your builds go sideways. Thanks for joining me. I can't wait to hear how you use Build Insights in your own projects. And if you ever find yourself wondering why your build is slow, this is where you start. Bye.